Anytime Learning presents classifying rational numbers. So to classify our numbers, we're going to use a Venn diagram. This is a nested Venn diagram, so it starts with the most specific group, which is here we have 6th grade boys with glasses. And then if we go out into the next rectangle, this is a larger group of just 6th grade boys. So the 6th grade boys with glasses are a smaller subset of the 6th grade boys. And then if we go out to the next rectangle, that's even a larger group, that's the 6th grade students. So the 6th grade boys are all a subgroup of the 6th grade students. And then we head out to the next rectangle. So 6th grade students are a subgroup of all students. So all students are made up of the 6th grade students and the 6th grade boys and the 6th grade boys with glasses. So we're going to use this Venn diagram to help us classify numbers. So now this is the same Venn diagram, only this time it has different numbers or different classes of numbers, like our natural numbers and whole numbers, integers and rational. What do you notice about these numbers in each of the groups? So if we start with the natural numbers, which is the most specific of all the groups, we have 5, we have 25, and 108. Notice these are all positive numbers. So if we move out to the next larger group, which is whole numbers are all the natural numbers here plus 0. So as we go from whole numbers to natural numbers, the only difference is that the natural numbers exclude 0. Whole numbers are all natural numbers and 0. So if we go out to the next group after whole numbers, that would be integers. So integers are not just all negative numbers. Integers are the negative numbers plus the whole numbers. So remember, the definition of integers was whole numbers and their opposites. So we have the whole numbers and their opposites. So just remember, integers are not integers because they're negative. Integers are integers because it's made up of whole numbers and their positives. So the largest group, like in our student group, the rational numbers are all the numbers that have fractions and decimals. But rational numbers include the integers, and they include the whole numbers, and they include the natural numbers. So let's really define this. If you're taking notes, you should make sure you write down that the natural numbers, we said, are all positive numbers, such as 5 and 25. Whole numbers are all the natural numbers, including 0. Integers are whole numbers, or its opposite, such as negative 137 or negative 9. Notice there are no decimals, no fractions. And then we have rational numbers. That's any number that can be written as a fraction in simplest form. So what does that mean? That means that a fraction, so how do we make a negative 9 a fraction? Well, we would have to, let's get the right thing here. So here we would have negative 9, and we would draw a fraction bar, and we would write a 1 underneath it. So to make any number a fraction, we would just draw a fraction bar and a 1 underneath it. That's because the fraction bar acts as a division bar, and 5 divided by 1 is still 5. So we haven't changed the value. It just means that we can write and make it written as a fraction. So again, rational numbers are, luckily for you guys in 6th grade, it's all the numbers that you know, because any number that you know can be written as a number over 1. Okay, so rational numbers include integers, whole numbers, and natural numbers. So here's another Venn diagram. This Venn diagram is a little different because this shows the intersection of whole numbers, integers, and rational numbers. So this is how you read it. First, you have to ask yourself, in this spot right here, this says that this is only integers, and this place is not connected to whole numbers or rational numbers. Well, since integers are part of whole numbers, that means that there's no integer that can stand by itself. All integers are rational numbers too, so we can't put anything here. What about whole numbers? Are there whole numbers that are not rational numbers? The answer is no, because we just said that rational numbers are all the numbers that you know. So if we look at this spot here, this spot here is the intersection between whole numbers and integers. So do we have whole numbers that are integers but they're not rational numbers? Well, the answer is no, because everything that we have are considered rational numbers. So do we have whole numbers that are also integers and rational numbers? The answer is yes. We have numbers like 8, because 8 is a whole number, but it is also an integer and is also a rational number. That's this sweet spot right here where it's intersecting all of those three categories. Well, what about negative 3/14 here? When we said, what about negative 3/14? Where would that go? Well, first I can see that it's a fraction. Therefore, it must be a rational number. And so, it can't be an integer because it's a fraction. So we'd have to put it in this place. And what about negative 23? Well, the best place for negative 23 would be in the integers. It's not a whole number because it's negative, so it has to be outside of the whole numbers, but it's still rational. So it has to be in this spot right here, where it's the intersection of the rational numbers and integers. And that's how you would use this kind of Venn diagram. Okay, so let's look at this number, negative 98. If you were to place negative 98, where's the best place in a Venn diagram for negative 98? What's the best group? Well, it is a rational number, and it is an integer. So it can be categorized as both. However, if you had to choose one, you'd probably say integer because that's the most specific of the groups. All right, true or false? The following Venn diagram correctly shows the relationship among different sets. So take a look at the diagram, and the diagram shows you that here's the space for all rational numbers. That's here, the biggest group. And then it says its next biggest group is whole numbers, followed by the most specific group, which is integers. Is that true? Well, we said that integers are actually whole numbers and their opposites. So really integers need to be out here, and then whole numbers need to be inside. So that is false. Next, the number negative 2.4 would be located in the shaded part of the diagram. So let's first take a look at the diagram and see where the shaded part is. So it looks like the shaded part is in this section that we're talking about, integers. So integers are whole numbers and their opposites. Can they have a fraction or decimal? The answer is no. So negative 2.4, because it has a decimal, it's not an integer. It has to be a rational number, which would be on the outside. This would be a rational number. So don't be fooled by the negative, because negative isn't what makes an integer. It's just part of the opposite of integers. Opposite of whole numbers. Okay, the next one says, let's see. Both of the following numbers have been correctly grouped. So here it says 3.4 is in the rational numbers and 3 is in the whole numbers. Do we agree? Well, yes, because rational numbers includes all numbers, and which is also fractions and decimals. So that's correctly placed. And is 3 a whole number? Well, it is positive, therefore it is in the correct space. All right, so this is going to require just a little thinking. The statement is all whole numbers are rational numbers. True or false? Okay, if you said true, you are correct. It is true. And that's because, remember, we said that rational numbers is the largest group, including every number that you know. So rational numbers includes the integers and it includes the whole numbers. So that answer is true. Some natural numbers are rational numbers. That is true. So, but are all natural numbers rational numbers? So again, the question is, okay, so here's the rational numbers, the very largest of the group, rational numbers. And in here are the natural numbers. Remember, this is whole, these are the natural numbers, and these were the integers. So to say that some natural numbers are rational numbers can't be true because it's really all natural numbers. So in this case, it has to be false because it really should be all natural numbers are rational. Okay. And the next one, so here was our statement that's false. Here is our next question or next statement. Some rational numbers are integers. Okay, that's kind of like the sum natural numbers. If rational numbers are the largest part of the groups, then that means that all integers must be rational numbers. So that's also false. Okay, so after the slideshow, you should be able to classify whole numbers, integers, and rational numbers using visual representations such as a Venn diagram.